Good morning, afternoon or evening year 13s. In this video we're looking at implicit differentiation, and this is when we differentiate a problem that has x's and y's in it instead of a problem that is y equals. So in this first example here we're asked to find dy by dx, and then we're asked to use it to find the tangent of this graph at this point. So let's focus on dy by dx for now, and I'll start by writing out our expression x squared plus y squared equals 25. You probably wondered why I hesitated so much drawing that out, but you'll see why in a minute. So what we're going to do when we differentiate this equation is we're going to write d by dx on both sides. And what that says is we're differentiating with respect to x. Now it is important with respect to what we are differentiating. So just to clarify that a bit more, that means that we've got d by dx of x squared and d by dx of y squared, and of course the derivative of 25 is 0, so we just have 0 on that side. So d by dx of x squared is easy. That's just 2x. And there's no problem there because we're differentiating it with respect to x. No worries. D by dx of y is similarly easy, except that because we've differentiated y with respect to x, we have to times it by dy by dx. Okay, now I'll let you sort of accept that for now, and we'll deal with the y a bit later on, but it does make sense with regards to the chain rule, and then that's all equal to 0. So we want dy by dx by itself, which means that we have to now solve this equation for dy by dx. So I'll start by subtracting 2x from both sides, and so that gives me 2y times dy by dx equals negative 2x, and then I'll divide both sides by 2y, so dy by dx will equal negative 2x over 2y, and so the 2's cancel out, and we have dy by dx equals negative x over y. So that's answered the first part of our question, which was to differentiate this and find dy by dx. Now we want to find the equation of the tangent at this point. So to find the equation of the tangent, we'll need the gradient, and the gradient is calculated when x is 3, and so but also we need y for this one, so y is negative 4. Okay, so the gradient is going to be negative 3 over negative 4, which is just negative 3 over which is just 3 over 4. So now that we have the gradient and we've got our point, we're going to use the gradient point equation. So y minus y1 equals mx minus x1. So we have y minus negative 4 equals 3 over 4x minus 3. Just check that I've got the right points. Yep. And so that's y plus 4 equals 3 over 4x minus 9 over 4. Let's times through by 4 to get rid of our fractions. So 4y plus 16 equals 3x minus 9. And let's just bring everything over onto one side, and that will give us, I'll bring it onto the other side, so 3x minus 4y minus 25 equals 0. And that's the equation of the line that is tangent at that point. Okay, so obviously the point of differentiation is to find gradients, and so that's why we've done that part of the question. But when you're differentiating implicitly, you're differentiating each term with respect to x, and any term that is not x must be multiplied by dy by dx. So I'll leave this video here, and we'll do one more where we go over another example.